Hello everybody, welcome to the 1.3 video on angles. All right, let's go ahead and get started. So angles, they consist of two different rays that have the same initial point. So basically they share the same end point. In this case, we've got ray BA and we've got ray BC. Okay, and again, notationally, ray BC and ray BA. Right? So two rays make up an angle. Right? Two rays make up an angle. Right? Naming an angle. So there's a variety of ways to name an angle. Right? So the main way, if you're given points on the angle, right, would be to take the angle and make a little angle symbol, and then you name it using 3 points. Okay? Now you got to make sure the middle point is the vertex. So A, B, C. A, B, C. The same angle, the exact same angle, can be named angle C, B, A. Okay? Does not matter if you go from top to bottom, bottom to top. As long as you use 3 points and the middle point is your vertex, you're good to go in naming your angle. This is probably the most common way that we name an angle because it's going to describe the angle each time. It's going to tell you which rays and which vertex we're using to name the angle. Right? Now, a couple other ways to name the angle, and there we can do that in this diagram. You can name an angle by just the vertex. Okay, so another way to name this angle is just by saying angle B. Now, this gets into trouble when you start having more than one angle at a specific point. Okay, but in this case, there's only one angle, and it's angle B. So we can name it angle B. The third way, if you have numbers written inside the angle, you can use the number to describe the angle. Right? Numbers are very helpful when you've got a lot of different angles and a lot of different lines crisscrossing all over the place. The numbers are a lot of times the easiest way to identify them and the quickest way to identify each specific angle. Right? But these are the different ways to name our angles. These are really important. We've got to be clear with these, and we'll talk more about it as we're going through because I'll show you why we're naming angles specifically the way we are. Right? So here we've got a picture here with a lot of different angles. Okay? There's a lot of different angles here. Now you may say, oh, there's 3 angles. Yes and no. There are 3 angles, but there's more than 3. Okay? So if you want to pause the video right now and try and write down all the different angles that you see, then you can check as we're going through them. All right? So go ahead, I'll give a second, and then I'll get started. Okay, I think the easiest way to start here is to start with the smaller angles and then get bigger. So there are 3 small angles here, and they're all marked with numbers. So I'm going to go ahead and write those 3 down. Angle 1, angle 2, and angle 3. Right? Gives us 3 angles, and I'm going to go ahead and mark them down here. 1, 2, 3. All right? We've got those 3 angles. Now, you might, well, that's all of them. Nope, that's not all of them, because there's some angles in here that are combinations of angles. All right? So I'm going to take one of these bigger angles that starts here and goes all the way to there. So it takes DE, ray DE, and ray DG. Well, that angle, let's name that angle EDG. All right, there's one. There's another big angle here, starting down here with DH and going all the way over to DF. Let's name that angle, angle HDF. Okay, there's 2 more. Right? Now there is one more angle, and this angle doesn't look like an angle, but it is. It's one that starts here at DE and goes all the way over to DH. We call this, and we're actually going to classify, it's called a straight angle. It makes a straight line, right? But it's still an angle, and we're going to name it angle EDH, right? So it looks like there are 6 angles shown here, right? Now, we could, like angle 1, we could have named that angle EDF or angle FDE. So there were 3 different ways to name this angle, angle 1, but I chose angle 1 because it was the quickest way to do it, all right? Now, what we got to be careful of, there's no angles that we could have just named angle D on here because all 6 of these angles have a vertex at D. Okay, so that's why in this case we can't just name it angle D. We've got to be more specific. Classifying angles. An acute angle, angle that measures less than 90. This should be all recap for you guys. A right angle, angle that measures where the measure equals 90, and an obtuse angle where the measure is greater than 90 degrees but less than 180 degrees. Okay? These are probably the 3 you learned about a long time ago. 90 degree, acute, right, and obtuse. We also have the straight angle, which we talked about briefly. That's an angle that measures 180 degrees. Basically, it makes a straight line. So a lot of times it's even hard to see that angle exists because it's just a straight line. But if you can identify 3 points and a vertex, okay, that vertex, even though it's a straight line, it's a straight angle. Okay, so classify and name this angle. So we got angle ABC. Let me go ahead and name it. Angle ABC, right? We could have said angle B as well. But this is 39 degrees, less than 90, it's acute. Classify and name the angle. Let's say angle ZYX. 99 degrees, more than 90, it's obtuse. Okay. Angle addition. Okay, these next handful of slides, these are going to be very similar to our segment slides. Okay, just like we had segment addition, we also have angle addition. So it says if D is in the interior of angle ABC, meaning that its point, this point D is contained somewhere inside, right? Somewhere inside angle ABC, right? Now we know that angle ABD, that smaller angle, plus angle DBC, this smaller angle, right? We know that adding those together would equal the measure of the whole angle, right? I should probably make this a different arc. So just like we use hash marks with segment lengths to talk about their size and the relation, whether they're equal or not, we can use these arcs to do this as well. So I made arc ABD a single arc, arc DBC a double arc, and arc ABC a triple arc to show that all 3 of these arc measures, that these angle measures are different from one another, right? And there could be the 2 smaller angles could be equal, but I don't know that. I'm not given that information, so I can't mark them as being equivalent. So here we have 2 angle measures, 26 degrees and 37 degrees. We can add those together. 63 degrees. So the measure, this is how we write the measure of angle ABC equals 63 degrees. If I ever do something wrong on a slide in class, I would tell you, raise your hand and tell me right away. With these pre-recorded videos, a little bit harder to do that, But if you see me make a math error, I'm going to be posting all these videos on YouTube. Put a comment in there, all right? Either on a YouTube or send me an email or send me a Google Classroom message. Let me know, okay? So I can make a correction and I can address it because I don't want you guys doing it wrong. And I make simple math mistakes too. I need somebody to check me up. All right. Here's two. We want to find the measure of angle AEC and the measure of angle AED. You guys can pause the video and give these a try real quick. After you unpause, I'll go through them. All right, the measure of angle AEC. So AEC, so we're looking at this angle plus this angle. So that's 60 plus 85. Looks like we got 145 degree angle. And then angle AED. So now we got this small angle, and this small angle. So we got to do the 145, which is the AEC measure, plus another 35. And it looks like it should be 180 degrees. Okay? Making angle AED a straight angle. All right. If the measure of angle MNJ is 72 degrees, I'm going to write this down. MNJ is 72 degrees. And the measure of ONJ is 125 degrees. So we're talking about the full angle. What is the measure of MNO? Okay, MNO. Well, just like with our segment addition, okay, we know that if we've got a big piece, basically the whole angle, and we know part of the angle's length, in this case MNJ, we can subtract one from the other to get what's left. So I can do 125 minus 72. Looks like we got a 53 degree angle. So the measure of angle MNO equals 53 degrees. Okay. Now, I apologize. Our equation editor does not work very well in Smart Notebook, so these less than signs, they should look like angle signs instead of that. But if you could bear with us, and when you're writing them down, please write down the angle signs and not a less than sign. We typically don't do much with them at the same time, so it shouldn't be any interference. All right, if EDH is a straight angle meaning it's 180 degrees, and the measure of EDG is 135, what is the measure of GDH? Same thing, 180 minus 135 should give us a 45 degree angle for GDH. Angle bisector. This is the same idea of a midpoint with segments, okay? It says ray BD is an angle bisector of angle ABC if and only if the measure of ABD is equal to the measure of angle DBC. So we're talking about two angles that are the same, okay? Now, I talked about how we can use the number of arcs. Well, you could also do arcs with hash marks to measure, to show the same equal measures, equal angle measures, okay? But again, we've got two equal angles that are put together here with the ray in between, right in the middle of the big angle. We call that an angle bisector, okay? It bisects the angle into two equal ones. Okay, in this case, we're told BD is an angle bisector of angle ABC. What is the measure of angle ABD? Right? Well, we know that the bisector tells us these angles are congruent. So angle DBC is 46 degrees. So is angle ABD. 46 degrees. BD is an angle bisector of angle ABC, and the measure of ABC is 96 degrees. So we're told the entire angle is 96 degrees. What is the measure of angle DBC? DBC, so this is the one we want to try and find. Well, we know that these two angles are equal. Angle ABD and angle DBC are equal. So if we take our full angle measure of 96 and divide it in half, we should have the measure of the two small ones, which is 48 degrees. All right. Okay, angle addition. Okay, angle addition with variables. So just like with our segments, we may be given variable expressions for the measure of the angles. All right. We're told that if angle ABC is a right angle, 90-degree angle, like it. Okay. What is the measure of ABD and the measure of DBC if the measure of ABD is 4x minus 20 and the measure of DBC is x plus 10? All right. We're going to use angle addition. So we got our 4x minus 20 plus x plus 10 equals 90 because it's a right angle. Combining my like terms, I get 5x minus 10 equals 90. Adding 10 to both sides, 5x equals 100. Dividing by 5, we get x equals 20. Now again, we weren't asked what x equals, but we need that to find our lengths. So we're going to plug 20 in here for my x values. Let's see, 20 plus 10, that's bottom one, that's going to be 30. 4 times 20 is 80, and 80 minus 20 is 60. And just to double check, these should add together and equal 90. 60 plus 30 does equal 90. Good job. All right. Let's see, I think we got a couple slides to go. Yeah. All right. So here we got if HIK equals 152 degrees, so the full angle is 152 degrees. What is the measure of angle JIH and KIJ? Pause the video, give this one a try. Okay? Pause this video and give this one a try. Okay? Using angle addition, yep, we are talking about these two expressions here. So we got JIH is 6x plus 50, and KIJ is 3x minus 15. Let's use angle addition to set them equal to 152. 6x plus 50 plus 3x minus 15 equals 152. Combining my like terms, I get 9x plus 35 equals 152. I'm going to subtract 35 from both sides. 9x equals, let's see, 35, so I can do 117. And I got to do 117 divided by 9. I get 13. All right. What is the measure of, so JIH and KIJ? We got to find these two measurements right here. So I'm going to plug 13 in. So I got, I'm not going to do these in my head. I'm going to put them in the calculator. 6 times 13 plus 50 is 128. And 3 times 13 minus 15 is 24. And I'm going to add these together, and I get 152. Okay, so we got our two measurements right there. We got them. All right, now these last two involve bisectors, okay? It says IJ bisects HIK. Find the measure of HIJ if the measure of HIJ is 2x plus 50, and the measure of JIK is 5x plus 5. Now we know that the bisector bisects the big angle into two congruent angles. So I can take these two expressions and set them equal to one another. Okay, I'm going to keep my x coefficient positive. I'm subtracting 2x from both sides. Subtract 5 from both sides. And then divide both sides by 3. I get x equals 15. Now I just need to find the measure of HIJ, so I'm going to plug that in here. And 2 times 15 is 30, and 30 plus 50 is 80. So I get 80 degrees for the measure of HIJ. Okay. All right, and our last one. Find the measure of angle XYZ if ray YW bisects angle XYZ, and the measure of XYZ equals 12x minus 14, and the measure of XYW equals 3x plus 5. This is a little tricky. You got to be careful and you have to read these angles. The first angle we're given here as an expression is angle XYZ. It's the full angle, right? So the full angle is 12x minus 14. The measure XYW, that's the smaller one, is 3x plus 5. So you're probably looking at it and wondering, well, how can I set up an equation? The key to this is that it bisects, okay? The ray bisects. So I know that this angle and this angle are equivalent. So even though I'm not given what angle WYZ is, I know that it's going to be equivalent, so it's also 3x plus 5. So we could use angle addition here to set up an equation, right? And we could get the 3x plus 5 plus 3x plus 5, we could do that, or we could just do 2 times 3x plus 5 to get the same thing. I like to add it together just because it keeps things consistent. So I'm going to write these down. 3x plus 5 plus 3x plus 5 equals 12x minus 14. Combining like terms gives me 6x plus 10 equals 12x minus 14. Subtracting 6x on both sides, I get 10 equals 6x minus 14. 12x minus 6x is 6x again. Adding 14 to both sides, I get 24 on the left equals 6x. Dividing by 6, we'll get x equals 4, right? Now, to find our full angle measure, XYZ, since we were given that expression, I can plug 4 in for x. 12 times 4 is 48. And 48 minus 14 is 34 degrees. Okay. Now, just in my eyes, I want to double check and make sure I did it right. So if I plug 4 in here into my x, y, w expression, it should be 17 because it should be half of 34. And 3 times 4 is 12. 12 plus 5 is 17, and it is half. All right, that covers our 1.3 material. Again, look for that assignment that goes along with it. Your assignments will be due by the end of next week. Would love to have them done before we have our second Zoom meeting. Best of luck on it. Feel free to email me questions if you have any, and have a great weekend.